Hello, everybody. So now we are going to discuss one of the things that relate to Bernoulli equation. It's kind of more of a graphical way of expressing the energy of the fluid. So we agreed that Bernoulli equation states that the energy of the fluid will be a combination of the three forms: the flow work, kinetic energy, and potential energy. And there are ways that we can or that we are sometimes interested in um, to see how the energy is changing while the fluid is flowing from one point to another. So as we see here, there is a tank that is filled with, let's say, water, with this liquid, and this fluid is flowing in this pipe. And at different points, we have a piezometer and a pitot tube uh, connected to the tube. And for each one of them, we can see that the height of the fluid indicates the energy or the pressure and the pressure and velocity, as we said before, of the fluid. Again, if you recall the piezometer, it shows how uh, or it indicates the pressure of the fluid in the pipe, and the pitot tube is gives a combination of both the velocity and the pressure, because the velocity at the inlet is zero. So the height here indicates both the kinetic energy and flow work, while this indicates only the flow work. Or the pressure and u square over 2g, depending on what units we are using. So if we put these pitot tubes and piezometers at different points on the pipe, we can visually monitor how the pressure and the kinetic energy are changing from one point to another. So to monitor the pressure, we can look at only the piezometers. So the piezometers will show us how the pressure is changing using this dashed line. Okay, so in the beginning the pressure was high, and then the pressure decreased because of the small diameter, so the velocity is increasing, so the pressure is decreasing, and then it's increasing again because the area increased, so the velocity decreased. So we can see how the pressure changes from a point to another by just looking at the piezometers. And the same for the pitot tube. The pitot tube gives us information about both the or the combined energy of the kinetic energy and the flow work. So from the difference, we can know that this is the kinetic energy and this is the flow work. And again, we can monitor the change of the total energy, which is the kinetic energy and the flow work, using the solid red line here. So this dashed line, we call it the hydraulic grade line. Okay, this is called hydraulic grade line, while the summation of both the kinetic and flow work are called the energy grade line. So the EGL is the energy grade line, HGL is the hydraulic grade line. And of course, you can know that the energy grade line is the summation of the flow work and the kinetic energy. So this difference here is the kinetic energy, okay, which is the difference between the hydraulic grade line and energy grade line is the U square over 2G. Okay, and of course here we are dealing with a horizontal pipe. So if we take into account also the change in the elevation, then it's not going to be only P over rho G, it's P over rho G plus Z. And for the hydraulic grade line, and for energy grade line, it's the same as hydraulic plus U square over 2G. So again, it's not something that we use for calculations, it's just to show how the energy is changing. There is one thing that it's worth noting here, that if this system is a system that follows Bernoulli equation, or it satisfies Bernoulli equation assumptions, we should have had a horizontal lines for the hydraulic and the energy grid lines in this region. Just the fluid is flowing, but this is not what happens in reality. What we see here is what really happens in reality, because while the fluid is flowing, there are friction losses and there is energy that's lost by the fluid, and this is what we call, or why we assume, an inviscid flow. Inviscid flow means that there is no loss, but here, since it's a viscid flow, means that there are losses. So This is what we should see in reality. And this is, by the way, what we are going to discuss in the coming videos about the modification of Bernoulli equation to make it suitable for other cases. For the hydraulic grid line and the energy grid line, this is one thing that is kind of nice about this grid lines. That you can see here, this is the energy grid line, this is the hydraulic grid line, the dotted one, and this is the P over rho g, and this is V square over or U square over 2g. And then you'd see that the area is decreasing, so the velocity increases. And as the velocity increases, the pressure will decrease because the flow work is converted into kinetic energy. So this is what you see here. The total energy is the same, assuming that there are no losses, of course, but the kinetic energy decreases and re-increases again. So this is a good thing to see here, to get better understanding of how the energy is changing and how it transfers from one form to another. One last thing, which is something we mentioned before about the mechanical devices, and we said that these mechanical devices that can change the uh, the energy of the fluid or convert the energy of the fluid into work or mechanical work. So we have the pump and the turbine, and we said before that the pump is a device that provides energy to the fluid. So you see here that before the pump, the energy is a little low, and now it increases as the fluid flows through the pump. On the other hand, the turbine is the opposite. The turbine consumes the energy in the fluid to convert it into electricity. So now we can see the grid lines, both grid lines are decreasing suddenly because of this turbine or the effect of turbine. So, I mean, this is quickly what we mean by the hydraulic grid line and the energy grid lines. And it might be a good introduction to the coming part where we are going to discuss the modified Bernoulli equation. So we will see how to include the pump and the turbine in the calculations in addition to the losses. So I'll stop here and I'll continue in the next video, inshallah. Goodbye.